Hello friends, welcome back to Cloud Pedagogy. Well, in the last session we understood about what is the necessity of build and test. In today's session, we see how we can work around these with an AWS service called AWS CodeBuild. With code commit sessions so far, we have collaborated between software engineers using source control, and I have my code committed to a source repository. So what comes next? Well, I will most likely want to be sure my code is in a good state and it builds successfully. But what do you mean by a successful build? A build will usually include automated testing to check the quality of the code and unit tests to exercise the code and make sure it's doing what we expect it to do. We'll talk more about testing in the later sessions. Basically, developers typically test their code in their own machines. If the tests are run manually, the developer might forget to run all the necessary tests. This can lead to statements like, "I was pretty sure we tested that." Also, problems can occur when they deploy the application in the target environments. The developer can say, "Well, it worked in my machine." That is the expression often used by the developers. Now, if any of these build steps, such as retrieving dependencies, compiling, packaging, or testing fails, then we will have a broken build. This is something we want to catch as early as possible. If I commit something that is breaking the source control, I am impacting others on the team. Basically, these are common issues encountered in the target environment, such as missing dependencies, mismatched versions, leftover artifacts, and missing configurations. Of course, I can run a build in my local development environment. When I do that, I can be pretty confident my code is in a good state. This is referred to as it works on my machine. To get some extra confidence, we can perform the build in a clean environment like of my laptop, somewhere to automate the build and test my code. As you heard previously, continuous integration allows the building and testing of our code earlier in the development lifecycle. The goal of continuous integration is to find and address bugs quicker, improve software quality, and reduce the time it takes to validate and release new software updates. So the team has decided on AWS CodeBuild for our continuous integration. So we understand that this is the place we can compile the source code, run tests, and create deployment packages. But what is the CodeBuild then? It is nothing but a fully managed build service in the AWS cloud. CodeBuild is a service. It gives us a great platform to perform quicker and consistently tested builds in a deployment-ready state. In AWS, we have some services, for example, Lambda. If you remember in our AWS fundamental course of Lambda session, we really didn't have to do anything, and in fact, we were completely unaware of what was going on behind the scenes. So we were getting a lot of help from AWS here, and we were doing a lot of prep behind the scenes. Similarly, a build is going to take your source, compile it, retrieve dependency packages from a repository like Node Package Manager or NPM modules or Java Maven artifacts. The output of the build will be packaged artifact ready for a deployment. Maybe this is a Linux RPM package, a Java var file, a Docker image, or even Windows MSI installer, and many more. This is a package that can be passed onto your deployment process to roll out and update. Unlike managing build machines yourself, CodeBuild will scale up and run multiple builds instead of leaving your build in a queue. With CodeBuild, you only pay for the service when you're using it. But how do we get our build process into CodeBuild? Basically, there are two things that we need to configure: a build project and a build spec file. The build project contains information about your build, like the source or location of your project, the environment which will configure the project with a Docker image and specs of the build environments, and the CodeBuild will provision that and run your build. It will include an IAM role too. Remember, roles are how services authenticate to services. If your build talks to an AWS service, this is the identity that will be used. And then logging. See, the log output of the build is absolutely needed to debug your builds. We can configure CodeBuild to write logs to Amazon CloudWatch logs and S3. Next, a build spec is a collection of build commands and related settings in YAML format. The code build uses to run a build. We will talk about that in detail in the next lesson, but let's understand the flow of how code build works with the diagram. In the first step, we need to provide CodeBuild with a build project, and a build project will define how CodeBuild runs a build. It's going to tell CodeBuild where to get the source, the build environment to use, the build commands to run, and where to store the build output. In the step 2, the CodeBuild uses the build project to create the build environment. And then in step 3, CodeBuild downloads the source code into the build environment and uses the build specification build spec, and the build spec is a collection of build commands and related settings that CodeBuild uses to run a build. Now in step 4, if there is any build output, the build environment uploads it to output to an S3 bucket. But we could also specify some other tasks such as sending build notification to an SNS topic. Now in step 5, while our build is running, the build environment will send information to CodeBuild as well as to the CloudWatch logs. So we will have a record of what all happened during the build. And finally, while the build is running, we can use the console, CLI, SDK or code pipeline to get summarized build information from CodeBuild. Now in code pipeline, it is a bit more limited information than, for example, the CloudWatch logs. So that is the process. Well, with that, I will end this lesson. Thank you for joining me, and I'll see you again in the next lesson. Until then, take care and be happy with your learnings.